Now that we introduced ordinary and singular points, we're going to talk about a theorem. This theorem says, well, if x equal to x of 0 is an ordinary point, for a differential equation that we defined at the beginning of our class, then we can always find two linearly independent power series solutions centered at x of 0. So y becomes power series Cn x minus x of 0 to n, and start from 0 goes to infinity, and then this power series converges at least on some intervals x of 0 subtracted from x less than r. So it means that we have x minus x of 0 bounded between negative r and r. So x is going to be x of 0 minus r and x of 0 plus r. What is r? R is the distance from x of 0 to the closest singular point. Okay, let's go over one example to feel more comfortable about this theorem. Example. Suppose we have the following differential equations: x squared minus 2x plus 5, the second derivative of y, plus x, y prime minus y equal to 0. So question says, what is the minimum radius of convergence about x equal to 0? So first of all, check to see if it's written in standard form or not, because we need to look for the singular points. Write it in standard form. The standard form becomes the second derivative of y plus x over x squared minus 2x plus 5 y prime plus negative 1 over x squared minus 2x plus 5 y equal to 0. So now you're dealing with these two rational functions. So since these two are rational functions, we need to find the singular points as the solutions of the denominators. The solution or solutions of the denominator. Remember that to define the domain of these types of functions, we say that, hey, we have, if you're looking for the real solutions, you say that, hey, r minus the zeros of the denominator. Otherwise, we have to specify all solutions, real and complex. X squared minus 2x plus 5 is equal to 0. Well, x becomes 2 plus minus square root of b squared minus 4ac, which is just 20, divided by 2. So as you can see, you have 1 plus minus, and here we get 2 after the division. So singular points are all complex values. Well, our theorem says at any ordinary points, note that x equal to 0 is an ordinary point. So by the theorem, we can find solutions for this differential equation. We can find two linearly independent solutions at this ordinary point. Theorem guarantees, assures us that we can find a power series solution of the form of Cn x minus x sub 0. X sub 0 is just 0, so x to the n starts from 0, goes to infinity. And the radius it says, well, the theorem says the radius as the distance from x sub 0 to the closest singular point. So we need to find the distance between 0 and the closest singular point. Well, okay, let's take a look at the graph x and y. This is my 0 that I'm dealing with. 1 plus 2i which is this point here, and the distance from the origin from 0 to 1 plus 2i help me to show that the distance from x to 0 is less than square root of 1 squared plus 2 squared, which is square root of 5.